Welcome back to Mathematical Misconceptions, everybody. Today we're going to be taking a look at inequalities and some of the rules that we have to follow, and one of the biggest misconceptions that I see with students all across the board. So let's say we have this compound inequality where we have negative 11 is less than or equal to 7 minus 3x, which is less than or equal to 16. So far, this looks good because negative 11 is the smaller number and 16 is the larger number. And if we were just to bypass the middle, we find that negative 11 is in fact less than or equal to 16. So far, so good. If you ever see the reverse is true, like somebody says negative 11 is greater than 16, doesn't matter what the middle is, it's ultimately going to be false. So that's one thing you always want to look for. Now, one thing I have to hit home is that whenever you're multiplying or dividing by a negative number, this is important because a lot of students forget when you're multiplying by a negative number, this also works as well. We must flip the inequality. And we're going to show that today. And we're going to find a solution for x that works, and then we're going to plug in numbers not only into the new equation or new chain of inequalities, we're also going to plug into the original to show it's in fact true, because whatever solutions you get has to always work with the original at the end of the day. If you're ready, let's get started. We're going to start by just bringing it down. Negative 11 is less than or equal to 7 minus 3x, which is less than or equal to 16. We're going to follow order of operations with what's in the middle right here to solve for x. So the first thing we're going to need to do is subtract 7 from all sides. Minus 7, minus 7, minus 7. These cancel, which is nice. Negative 11 minus 7 is negative 18, which is less than or equal to negative 3x, which is less than or equal to 9. Check the extremes. Negative 18 is in fact less than positive 9. So far, so good. Now we're going to divide by negative 3. Dividing is the easy part, but it's remembering to flip the inequality that stumps a lot of students and gets some easy points missed. So we're going to divide by negative 3, divide by negative 3, divide by negative 3. And then we just follow suit on everything. Negative divide by negative gives us positive 6. Negative divide by negative just gives us x. And then finally, positive divide by negative is going to be negative. So we have negative 3 right there. So you can see here, everything was less than. Now here, it's greater than. And now we check the extremes again. 6 is in fact greater than or equal to negative 3. So this has to be true. If you forget to flip the inequality, just look at the extremes and ask yourself, is it true? If you have that negative 3 is greater than 6, then it's utterly false. And you want to flip the inequalities or double check your work along the way. Now, as I promised you, we are going to check our solutions. So the first thing that I'm going to do is I'm going to create a number line. Normally, when I create the number line to check my work, I just deal with the extremes of the solution. So 6 is on the high end, negative 3 is on the low end. Now, some students look at this and they see that the number line is flip-flopped. You can feel free to flip this inequality, in fact, as such. Negative 3 is less than or equal to x, which is less than or equal to 6. I prefer to see it this way because I see the numbers from least to greatest. Least to greatest. Hope that makes sense to you. Now what we're going to do is we are going to just double check some things in the regular solution, and then we have to plug things back up here as well. So if we plug in negative 3, yes, that works. If I plug in something in the middle, let's say 0, yes, that works. 6 works. 7 doesn't work. Negative 4 doesn't work. So when we fill in the number line with our solution range, it's going to be from negative 3 to 6 inclusively. So we can include the extremes as well. Now we're going to go ahead and dedicate a couple test numbers. So let's say negative 4, 0, and 7. So this is for checking your work and if you have time to check your work. I highly recommend to students that inequalities such as this can be a little time consuming, so you want to save the checking for the end and be confident in your algebra. Let's go ahead and check the extremes. We're going to start with negative 4. We're going to plug it into the original. Negative 11 is less than or equal to 7 minus 3 times negative 4, which is less than or equal to 16. Now we just go through straight order of operations. So we have negative times negative is positive, 7 plus 12, which is less than or equal to 16. And we see negative 11 is less than or equal to 19, which is true. but it's not less than or equal to 16. So this part of the inequality might be true, but this one's not. So we have to chuck it out. So -4 does not work, which is good because it's not in our region anyways. The next one to check is really easy. It's 0. I always tell students, pick easy numbers. Don't pick numbers that complicate your life. Throw in a 0 right here. What happens? -11 is less than or equal to 7, which is less than or equal to 16. That is true across the board. Love it. Finally, let's choose 7. Don't do 6.05. I want to keep the math simple, right? -11 is less than or equal to 7 minus 3 times 7, which is less than or equal to 16. Go through order of operations as always. 7 minus 21. I'm sure you can see it from here, which is less than or equal to 16. And then finally, -11 is less than or equal to 7 minus 12. 21 is -14, which this part is already completely untrue, which is less than or equal to 16. So every link in the chain has to work, right? This link might work, but this link does not. So we say that this chain is utterly broken. Break that chain, right? And we say that this doesn't work. And from there, you verified your solutions by simply plugging in your solution region into the top equation. Now, if you want to test more numbers, that's fine. But at a bare minimum, when you have something like this, you generally just want to test 3 numbers. 2 that are outside of the extremes and 1 that is inside. And once you get that solidified, you can be confident that your answer is 100% correct. Alrighty, so that was mathematical misconceptions with inequalities. If you have any questions, drop a comment below. And otherwise, I'll see you in the next one. Thank you.